We're going to look at 1.3.3 algebraic combinations, and we're also going to take a look at 134 composites. But in 133, no new vocabulary, but we do have one rule. It's properties of continuous functions. So that rule goes like this. Algebraic combinations of continuous functions are continuous wherever they are defined. If we have continuous functions f and g, and they're both continuous at some particular constant c, then all the following combinations are also continuous at x equals c. And in order to make this a little more concrete, let's consider maybe f of x to be the function sine of x, and let's let the g of x be x squared. We know sine x is a continuous function because it's the sinusoidal wave. We know x squared is continuous because it's a parabola. So, first of all, sums of continuous functions are continuous. So that means the function s, or sine of x plus x squared, is continuous. The differences are continuous. So sine of x minus x squared is continuous. They're products. So that means sine of x times x squared is continuous. Or if we reversed the order, x squared sine of x, that would be continuous. A constant multiple, so we could multiply the number 2 or any other constant number by sine of x and still get a continuous function. And finally, the quotient of two continuous functions, as long as the y value of the denominator is not 0. So if we looked at sine x over x squared, this is continuous as long as x is not equal to 0, because 0 squared is 0. Next, what about composites? So when we say composite, we're talking f of g of x. We're talking one function into another. No new vocabulary, but we are going to look at the rule for composites of continuous functions. And it goes like this. All composites of continuous functions are continuous. This means that composites such as the sine of x squared, so x squared went into the sine function, or the absolute value of the cosine of x. So cosine of x went into the absolute value function. Those are all continuous because they're composites or compositions of continuous functions. Sine x is continuous, x squared is continuous, absolute value is continuous, cosine x is continuous. So the formal rule or theorem goes like this. If f is continuous at x equals c and g is continuous at f of c, then the composition f or g of f of x is continuous at that constant. And the diagram above explains it pretty well. If you begin with a constant c and you plug that constant into the function f, the output is f of c. Then if you take f of c and plug that into the function g, the output should be g of f of c. So as long as g is defined at f of c, then the composition of f and g is continuous. So here's an example. We're going to use that previous theorem to show that y equals the absolute value of x sine of x over x squared plus 2 is continuous. Well, this looks to me like we have f of x being maybe absolute value of x and g of x being x sine x over x squared plus 2. This is continuous because the absolute value function is known to be continuous. And this is continuous by the properties of, properties of combinations of functions from 1.3.3. So now we have a composition f of g of x. F of g of x is continuous. And that's everything for 133 and 134.